Hello everyone, myself Heming Satwara, and today's session we are going to discuss about multi-stage amplifiers. So now first we have to discuss about what is amplifiers. So in electronics and electrical, whenever you are amplify the signal, you just need amplifiers. Amplify, that means it is going to magnify your signal. For example, you have 5 voltage, then it will be 10 voltage and more than 10 voltage. So this is basically magnification or amplification. Now in this session we are going to discuss about various types of amplifiers. So let us discuss about first what is multi-stage amplifier. First of all, we have to remember this: in electronics and electrical engineering, most of the things coming from its name. For example, multi-stage amplifier, as per its name, multi-stage, that means there are number of stages are available for amplification method. So here you can see multi-stage amplifier diagram, in which we are going to use number of stages for amplification. Now there is a question, why we are going to use number of stages? So first of all, we have to understand that whenever we have to get more number of gain, then we need to use multiple stages of amplifier. So that's why we are using here multiple stages or multi-stage amplifiers. In amplifiers, cascading can also be done for getting an accurate input and output impedance for exact applications. So in this amplifier there are 3 multi-stage amplifier types. For example, RC coupling amplifier, transformer coupling and direct coupling. In this session we are going to discuss about RC coupling and direct coupling amplifier. So here you can see Vs, which is known as supply voltage, which is connected with this Rs. This is basically series resistance. Whenever we are going to apply your supply voltage, so it is passing from the various stages of amplifier, and then we will get output at the RL side. Now let us discuss about RC coupling amplifier. So as I told you earlier that in electronics and electrical engineering, most of the things coming from its name, RC coupling. So it stands for R, that means resistor, C, that means capacitor. So here you can see mostly resistor and capacitor components are going to be used. Now whenever we are going to apply input at this particular first stage of amplifier, so it is initially low level. So it is passing from the various components which is indicated over here. Capacitor. Now why we are going to use capacitor over here? So basically capacitor allows AC signal and it blocks DC signal. Now moving towards R1 and R2. Why we are going to use this biasing resistor? This is known as biasing resistors. R1 and R2, which is used for biasing the Q point. So in which whenever your Q point is stable, so you will get amplified version of that circuit. Thereafter, here you can see one transistor is connected and its emitter side RE and its parallelly CE is connected. Now CE, which is known as bypass capacitor. Now what is the purpose of bypass capacitor in this amplifier? Whenever we are going to bypass capacitor, your AC flowing from particular that bypass capacitor. If we are not connecting this bypass capacitor, then your voltage drop will be increased, and due to this your gain will be decreased. So for improving your gain, we have to use bypass capacitor across this RE. We will get output across this load resistor, and it will be input from that coupling capacitor. Now this is the reason we are going to use coupling capacitor in between stage number 1 and stage number 2. Why? Because coupling capacitor allows only AC signal. If there is a DC component, so it will be blocked again and allows to pass AC to the stage number 2. Now in stage 2 we applied input of AC signal. So again it will be amplified and we will get more power at the output side. Now there may be a question arise in your mind. Why we are going to this various types of stage 1 and stage 2? Initially, whenever you are applying voltage, for example, it is 5 voltage, you will get 180-degree phase shift across this stage number 1. Then, whenever you are feeding it to the stage number 2, so you will get another 180-degree phase shift of that input of stage number 1. Then, you will get amplified version of that input. So finally, you will get 180-degree phase shift. That means your first input and your final output, it is in same phase. So that's why we have to use two different stages of this amplifier. Now let us discuss about advantages and disadvantages of RC coupling amplifier. So first, advantages. The frequency response of RC coupling amplifier provides constant gain over a wide frequency range, hence most suitable for audio applications. Now, why it is providing wide frequency range? Because in low frequency, that means it is less than 50 hertz. It is lower gain. After that, the range 50 hertz to 20 kilohertz, it provides fixed gain and constant gain, which is very large. Thereafter, more than 20 kilohertz, it will be decreased. So it says it provides constant gain over a wide range of frequency. Number 2, the circuit is simple and has lower cost because it employs resistors and capacitor, which are very cheap. Number 3, it becomes more compact with the upgrading technology. So basically these are the advantages. Now moving towards disadvantages. The voltage and power gain are low because of effective load resistance. Because we are using here RL, so its voltage and power gain will be low. Number 2, they become noisy with age. Number 3, due to poor impedance matching, power transfer will be low. So this is disadvantage. Now, application of this RC coupling amplifier are: it is widely used as voltage amplifiers. Due to poor impedance matching, RC coupling is rarely used in final stages. They have excellent audio fidelity over a wide range of frequencies. So we are going to use this RC coupled amplifier in particular audio amplifiers. So we have discussed here RC coupled amplifier. Now moving towards another amplifier which is known as direct coupled amplifier. So as per its name, direct coupled, that means there is no active or passive component in between stage number 1 and stage number 2. That's why it is known as direct coupled amplifier. In between stage number 1 and stage number 2, you can find one PNP transistor, but you can directly connect T1 to T3. So no need PNP transistor. So same operation which we have discussed earlier for the RC coupling amplifier. Now here you can see the input signal when applied at the base of transistor T1, it gets amplified due to the transistor action, and the amplified output appears at the collector resistor RC of transistor T1. So basically this is modified version of RC coupled amplifier. So we are removing resistor and capacitor from that particular RC coupling amplifier. Now, advantages and disadvantages of direct coupled amplifier. The circuit arrangement is simple because minimum use of resistors. The circuit is low cost because of absence of expensive coupling devices. Cons: it cannot be used for amplifying high frequencies. The operating point is shifted due to the temperature variations. Now, whenever you are continuously flowing input from that particular stages, due to this there is a temperature variations, and due to this Q point will be shifted. Now, thus you will get distorted version of your amplified output. Applications: low frequency amplifications and low current amplifications. So these are the basic amplifiers in which we can see RC coupled is most useful amplifier, whereas DC, or we can say direct coupled, it is also used, but it minimizes the component. That's why it is very cheap compared to the RC coupled amplifier. So that's it for today's session. Thank you.